this is the activity on area of plane figures. The objective of this activity is to calculate the area of different plane figures using appropriate formulas. So we will be deriving the formulas and we will be trying to understand the relationship between the dimensions and area. So we will first try to understand what are dimensions and how the dimensions are related to the area of a plane figure. Let's first understand the shape of a square. In a square, we have the four sides which are of equal length, and the only dimension we need to know is the length of the side. So if we assume that the side length of a square is A, then this dimension, that is the side of the square, is related to the area as side into side. So you just have to do side square to get the area of a square. Likewise, if you have a rectangle, then a rectangle has one more dimension than a square. Because a square has only one side, all the four sides are equal, the length of a rectangle is different than its width or breadth. The length is represented by L and the width is represented by B. So these two, the length and the width, they are known as the dimensions of a rectangle. Let's now relate the area of a rectangle with its dimensions. If you multiply the length and breadth of a rectangle, you will get its area or the space occupied by this rectangle. The third figure which we will be taking up in the activity is the triangle. Whenever you have any triangle, let's say a scalene triangle in which all the three sides are different, you just need to know its base. That means the length of the side which is horizontal to the ground, parallel to the ground, and the base can be represented by B. So from the opposite vertex, we will draw a perpendicular like this, and this is known as the altitude or the height of the triangle. So the two dimensions which we should know for a triangle are its base and its altitude. Once you know the length of B and length of H, we can find the area of this triangle by using the relation half into base into height. And finally, we have the fourth figure, which is a parallelogram. As you all know that in a parallelogram, we have two pairs of opposite sides which are equal and parallel. So a parallelogram looks like this. Now in case of a parallelogram also, just like a triangle, we should know its base represented by small b and the altitude drawn from the opposite vertex, that is this line, which makes an angle of 90 degree with the base. If you know this height or the altitude, then to find the area of a parallelogram, we just have to multiply the base by its length of altitude and we will get the area. So this is the concept in this particular activity based on finding the area of plane figures. The material required to conduct this activity include a protractor, a ruler, pencil, that is all the geometrical instruments, the scissors to draw the cutouts and to cut the shapes of the squares, the rectangles, the parallelograms and the different other shapes for which area has to be found out. So now let's see how to conduct this activity. So to perform this activity on area of plane figures, the first figure which we have taken up is a square. So in the observation table, I am going to write a square here. Now a square has only one dimension, that is its side. So as you can count along the length, 1, 2, 3, 4. 4 small squares are there. So the dimensions are its
side, which is denoted by small a. The formula used to find the area of this square is side square, or a into a. Now, to find the calculated area and to verify it using this cutout, we will be counting the squares along the length 1, 2, 3, 4. So a becomes 4. So 4 times 4 will give us 16, and this 16 happens to be the area of this particular square. Now, how do you verify it using the calculated area? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can see that the total number of complete squares inside this big square is 16, and therefore it verifies that the formula a square, that is a into a, and the calculated area using the unit squares is exactly 16 centimeter square. Likewise, if in place of this square we have a rectangle just like this, you can see in this rectangle we have two dimensions. So we will write a rectangle here, and it has a different length and a different width. So the length of the rectangle is represented by small l, and the width is represented by small b. Now these are the dimensions of a rectangle. If we want to find the area using these dimensions, then we just have to multiply length by its width to get the area. So what will be the area using the formula? Let's count along the length. 1, 2, 3, 4, 5, 6. So in place of L, we will put 6. And what about the breadth or the width? 1, 2, 3. So 3 here, and that gives us the answer as 18. Can we verify this using the calculated area using unit squares? Let's count the total number of small squares in this figure. 6 plus 6 plus 6. It is 18, and therefore the calculated area is 18 centimeter square. Likewise, if you have to calculate the area of a triangle, here I have taken a particular kind of triangle. I'll show you when I rotate it. This triangle which I have taken up is actually a right angle triangle. So if you rotate it like this, you will see that this is a 90-degree angle, and therefore it is a right angle triangle. So what are the dimensions of a right angle triangle? It is the base, which is b, and the altitude or the height of the triangle, which is denoted by h. And what is the formula used? It is half into base into height. If you can count along the length here, the base half into, how much is the base here? 1, 2, 3, 4, 5. And how much is the height here? 1, 2, 3, 4, 5 again. So we have this calculation as 25 by 2, which is 12.5 centimeter square. Now can we verify that by counting all the small squares? Now let's verify this using the counting of unit squares. Let's count how many unit squares are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 complete squares, followed by there are some half squares. You can see this 1, 2, 3, 4, 5. There are 5 half squares. That means 5 times half. And 5 times half happens to be 2.5, and that gives us the same area, 12.5 centimeter square. Similarly, if we take a parallelogram, now we are changing the figure and we will be writing here the next figure, which is a parallelogram. Now in a parallelogram, what are the dimensions? So if you derive the formula of a parallelogram, you need the base of the parallelogram and the height of the parallelogram, the distance between the parallel sides. So if you know the base b and the height, which is h, if you multiply base and height, you will get the area of this parallelogram. So let's count along the base. 1, 2, 3, 4, 5, 6. So this is 6, and the height actually is this part, which I am darkening right now. This is the distance between the two parallel sides. So how much is this? 1, 2, 3, 4. So the area of this parallelogram comes out to be 24. And now let's verify this using counting of complete squares. So if you see in this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. These 20 are complete squares. Rest of them 1, 2, 3, 4, 5, 6, 7 and 8 are half squares. So how many were complete? 20 plus 8 times half, and 8 times half we know is 4, and that verifies that the area is 24 centimeter square. So I have verified this using 4 different figures. You can take up some different figures apart from these 4 to complete this activity and fill up this observation table.